Here we're looking at a linear programming problem, and because it's a word problem, the difference here is instead of being given the objective function and the constraints, we're going to have to come up with the objective function and the constraints based on the information that's given. All right. So as we look at this thing, it looks like we're making t-shirts and sweatshirts to sell as a fundraiser. The t-shirts are going to take 10 minutes each and cost $4 to make. The sweatshirts are going to take 30 minutes each and cost $20 to make. It looks like we have a total of 20 hours to make these things and $600 to spend. And we also want to make at least 50 of these t-shirts and sweatshirts combined. And then the last piece of information here they give us is that we're going to sell these, the t-shirts for $10 each and the sweatshirts for $40 each. And of course, the idea here is to maximize our profits. We want to make the most money that we can for this fundraiser. All right. So I'm going to start off with the objective function. Since that's the thing we're really concerned with, that's where what we're trying to maximize is the profit. So for the maximize the profits here for the objective function, I'm going to say P for profits equals, well, I just need to know how much I'm going to make on each of these things. When I look at the t-shirts cost $4 to make, but we're going to sell them for $10 each. So we're going to make $6 for each t-shirt. And so what I'm going to do here is I'm going to call t-shirts X. So the t-shirts I'm going to refer to, let me do a little bit better job with that. But I'm just going to call the t-shirts X, and I'm going to call the sweatshirts Y here, just to make things pretty easy for us. So the t-shirts I'm going to call X, and the sweatshirts I'm going to call Y. Okay, just to define some variables. And so the t-shirts, they were $6 each, so it's going to be 6x is how much I'm going to make on each of those. For the sweatshirts here, when I look at the sweatshirts, they were costing $20, but we're going to sell them for $40, so I'm going to make $20 on each of those. So plus 20y. And this describes the profits that are to be made here. So the profit is going to be 6x plus 20y. That's my objective function. All right. Now I need to come up with some constraints. And really, when you think about constraints, there are restrictions on what we can do here. All right. And we had a couple of things that are restricting what I can do. First of all, the time that it takes, and then the cost of each of these things. So let's start with the time. When I look at this, again, the time for the that I have here, 10 minutes for the t-shirts, 30 minutes for the sweatshirts, and I have a total of 20 hours. So what that's saying is it's saying that basically for 10 times X, that's the number of minutes it's going to take me to do all these t-shirts, plus 30 times Y, that's the amount of time it's going to take me to do the sweatshirts. That amount has to be less than or equal to the 20 hours. And keep in mind, since each of these was in terms of minutes, my hours are also going to have to be converted to minutes, so that's 1,200 minutes. Okay, so basically I get this little bit of a restriction because of the time crunch that we're under, and so what I say that I have to make these in under 20 hours. Okay, and that's what this is describing. And then the other thing that I'm given here is the cost. Each of these is going to cost $4. Each of these is going to cost $20, and I only have $600 to spend. So when I think about that in terms of an inequality, that means that 4 times the number of t-shirts, and I'm going to use a different color for this actually, just to help me keep this straight when I go to graph this thing. So 4 times the number of t-shirts plus 20 times the number of sweatshirts, that has to be less than or equal to $600 because that's all I have to spend for this particular example. Okay. And then as I look across this thing, there's one other restriction that I'm given right here. This guy, the fact that I want to make at least 50 t-shirts and sweatshirts combined. So what that's saying here, again I'll use a different color here, is that X plus Y, we want that to be greater than or equal to 50. All right, we want to have at least 50 of these things to spend or to sell. Okay, so these are the three restrictions that are obvious. But there's actually 2 more here as I look through this thing. And really, I can't really see those restrictions in the problem itself. There's not really anything that mentions those. But really, they're kind of given. They're kind of assumed that X has to be greater than or equal to 0 and Y has to be greater than or equal to 0. Those are the 2 restrictions that aren't really listed here, but they're kind of obvious when you think about it. I can't have a negative number of t-shirts, and I can't have a negative number of sweatshirts. So obviously we're going to have to be in the positive realm, and our graph is set up that way as well. So now I'm just going to go ahead and graph these things. So I'm going to start with the last two because they're kind of already graphed here. It's on top of my axes, and you can't even see those as I draw them because we're just on top of the axes, and that's it. And that's why I chose black for those, because they're kind of already drawn. It's my x and my y axis. All right, so we'll leave that as it is. Now when I go to graph this thing, I can see that I'm going to have some pretty large values in here. For this one, like I would start by graphing my x and my y intercepts, and I can see that my x-intercept for this one is going to be 120. My y-intercept for this one is going to be 40. So I'm going to have to scale this thing up appropriately. All right, as I start to think about these values that I'm going to have to deal with. So like over here, I might go by maybe like 5s as I count up on this thing. And I'll label every other, so maybe I'll call this 10. Okay, and we'll see that where that leaves us. See if we have enough space there. On the other axis, maybe I'll go by 20s or something like that. So 40, 60. Okay, and we'll see where that leaves us and see what happens here. So this first function, it's got a y-intercept of 40. So I come up here to 40 and I plot that point. And it's got an x-intercept of 120, so that's down here. And I can just use that information to graph this thing. All right. And again, I don't need to extend that graph like I did on each side of the axes, but I did anyway, so we'll just leave it the way it is. The next one, it looks like I have an x-intercept here. When I do 600 divided by 4, that's going to give me a 150. And then I'm going to have a y-intercept when I divide by the 20 there. It looks like it's going to give me a 30. So I get 150, which is way out here somewhere, and I get the 30, which is over here somewhere. And again, I'm going to graph that as best I can. With the next one, the x-intercept and y-intercept are both 50, so I've got a 50 here and a 50 down here. I'm going to go ahead and graph that line as well. And so now I want to start to narrow this thing down. So as I look across here, the first equation, basically if I were to solve that for y, I want to be less than that equation, so I want to be less than those values. So the line in blue, I want to be below that line, so everything over here. So it kind of narrows it down to these couple sections that are down here, which means not going to be any of the sections above that. The red line, once again, I'm going to be below that red line, so that kind of narrows it down a little bit. So when you think about just those two restrictions, kind of narrow it down to these two sections right here. All right, so now I know it's going to be one of these because I have to be below those. The next one, I want to be greater than that green line. And so really it narrows it down pretty nicely for me. It narrows it down to this last section right in here. So the section that I'm actually going to end up shading here, I'm going to use my crayon to shade it in. I'll use purple, is this section right here. And again, those the restrictions of the x and the y axis are pretty obvious, so I didn't really mention those, but I have to be in this positive realm up here, all right? So when I look at this thing, I have a couple vertices here. I've got one here, I've got one here, I've got one down here, and I've got one over here. So I've got 4 vertices, and 2 of these vertices are easy to identify. This one down here, because we graphed it as the ordered pair 50, 0, because it was an x-intercept. And this one right here, we also graphed as 120, 0. But the issue we run into is these 2 vertices up here. I can't really tell exactly where they are on the graph. They look close to certain values, but maybe it's tough to tell, and if my graph isn't super accurate, it's going to be difficult to find those. So what I have to do to find out where those lines intersect is I have to do a system of equations, all right? So that first intersection is between the red line and the green line, and this is why I labeled those. The red line being the 4x, let me try that again. being the 4x plus 20y equals 600. That's the line that's in red. And then the green line being the x plus y equals 50. I have to solve this system of equations in order to find out those intercepts. And the first thing I would do here is I would divide this entire first equation by 4, which is going to leave me with an x plus 5y equals 150. And now from here I can solve this using elimination. When I use elimination on this, I'm just going to multiply that entire second equation by a negative. And what that leaves me with then when I add these up, it's going to be a negative 4y equals a negative 100. I divide and I find out that y equals 25. And then of course I have to plug it back in, and when I plug it back into one of these guys, I'm going to find out that my x value is also a 25. Alright, so I'm identifying this vertice up here as 25, 25. And then the next one, again, I have to do the same thing. I have to set up a system of equations here, and that's between the red line and the blue line. So I'm going to write each of those down. So I've got the 10x plus 30y equals 1200. That's my blue line. The red line, once again, is the 4x plus 20y equals 50. Or sorry, equals 150. Sorry, equals 600. I can read. I understand how reading works. Let me try that one more time, 600. I kept looking at some of my other equations down here. But now each of these I can divide to make this a little bit simpler. So I'm going to divide this first one by 10, and that's going to leave me with an x plus 3y equals 120. I'm going to divide this entire second one by 4 again, which is what I did before. Just x plus 5y equals the 150. And then from here, I'm going to solve this one by elimination again. I'm going to multiply the entire second equation by a negative 1. And then when I add these up, it leaves me with a negative 2y equals a negative 30. I divide and I find out that y equals a positive 15. And then, of course, I have to plug this thing back in. And when I plug it back in, I find out that x equals a 75. Okay? And you can plug it into either one of those, but we're just solving that system of equations. So now I've finally identified my other vertice, which was the 15, 75. And when we look in our graph, those points make sense. Now I'm going to rewrite each of these, so I'm going to rewrite these down here. Because what I have to do is I have to identify my maximum minimum. I had the 25, 25. The 75, 15. The 50, 0. And the 120, 0. And the last thing I need to do, if I recall, my objective function was profit equals 6x plus 20y. Well, I need to plug each of these ordered pairs in and see what I get so I can find the maximum value. All right. So I plug each of those in. Looks like I get a 650 for the first one. So I'm going to plug that second one in. That one looks like it gives me a 750. And then I plug the next one in. It looks like that one gives me a 300. And then I plug this last one in, and it looks like that last one gives me a 720. All right. So as I look down through here, I can see my maximum value. My maximum is right here. It's the 750. I can see my minimum. I wouldn't want to just make all t-shirts. So to maximize my profits, the maximum profits I can make with these constrictions is $750. That's what this guy is representing. And then this is telling me the number of t-shirts and the number of sweatshirts. So if I want to maximize my profits for this one, I have to make 75 t-shirts and 15 sweatshirts, and that'll give me $750. And that's maybe not exactly what we would expect out of this thing because we make more money off the sweatshirts, but it takes so much less time to make the t-shirts that it actually is more profitable in the long run to make more t-shirts. Okay? So that's it for the word problems. Again, there's a lot of time-consuming and a lot of places to make mistakes here. So just be careful, take it one step at a time, and that's all there is to it.